Okay, students, so we're doing section 4.5 in the WebAssign. So this section is on integration using use substitution. All right, I just paused it because I can't get my little thingy. Oops. My box is it's in the way. I've never done. Oh, there we go. Okay. See this? There's no good place to put this box, truthfully. All right. So there's my pen. All right. Now this is all messed up looking. But I have to. Okay, I gotta record it now. Okay, so we're doing some use substitution here. All right, so you're always going to look for your inside function, and that's going to be your u. And in this case, my u is 5 plus 9x. My du would be the derivative of 9x, since the derivative of 5 is 0. So that's 9dx. And if you notice, we have the exact du already in our function. So there's the 9dx. So I'm just going to rewrite my integral as the integral of u to the 8th du. So that's just using your power rule. That's a simple integration. So we add 1 and divide by the new exponent. So that's u to the 9th over 9. And go back and substitute your u, which was 5 plus 9x. So 5 plus 9x to the 9th divided by 9, or you can actually write it as 1/9 times 5 plus 9x to the 9th. So remember, on paper you would always put your plus c since these are indefinite integrals, but the WebAssign puts the plus c for you already. So they make it a little easier. So let's check that answer. Okay. So number 2, we have the integral of x squared minus 4 cubed times 2x dx. So we need to let u equal our inside function, which is x squared minus 4. Du would be 2x dx. And just like the last problem, we have the exact du. So that means we can rewrite this as the integral of u cubed du. And that's just using the power rule again. So add 1, that would make the exponent 4, divide by 4. So 1/4 u to the 4th plus c. So 1/4 times x squared minus 4 to the 4th plus c. Remember, you can use your shortcut, the Shift-6 key, to do the exponents. It makes it a little easier. Well, obviously not there, so let me go over to the side. Let's see. Okay, there we go. Sometimes doing this Blackboard Collaborate messes things up on the computer. Okay, like right there. So that did not write it as an exponent. So let me try again. Okay, here we go. All right. So number 3, we have the integral of x squared times x cubed plus 1 to the third dx. So let's let u equal x cubed plus 1. du would be 3x squared dx. All right, so looking at our problem, we have the x squared dx. So I'm going to circle that, but we do not have that coefficient of 3. So if I were to multiply that by 3 to get our du, then I'm going to have to compensate that with a 1/3 in the front of my integral symbol. So we have 1/3 integral. We're going to substitute u in place of the x cubed plus 1, so that's u cubed. And now I have the entire du, 3x squared dx. So u cubed du, so 1/3 u to the 4th over 4. So now I have 1/12 u to the 4th, and I'm going to go ahead and substitute what the u was, which was x cubed plus 1 to the 4th plus c. All right, so our next problem, we have the integral of x over 1 minus 5x squared cubed dx. So we're going to let our inside function, or our u, be 1 minus 5x squared. So our du is negative 10x dx. Okay, so I have an x in the numerator. So there's my x dx, but I'm missing a negative 10. So if I put a negative 10, I have to compensate with a negative 1/10 in front of my integral symbol. So the problem would become negative 1/10, and then rewriting everything with our u and du, we would have du over u cubed. Okay, so we want to bring that up to the numerator. So let's make that negative 1/10 integral of u to the negative 3 du. So we add 1. So that would be u to the negative 2 divided by negative 2. And let's see, that's going to simplify to 1 over 20. U to the negative 2, and my u was 1 minus 5x squared, which you could leave that to the negative exponent. WebAssign will accept that, or if you want to drop it to the denominator and make it a positive, we would have 1 over 20 times 1 minus 5x squared, the whole thing squared, plus c. And more than likely on a multiple choice test, the answer would probably be rewritten with a positive exponent. So that's just something you need to make sure you know how to do. Okay. Number 5, we have 1 over the square root of x. So I'm going to let u equal 8x. du would just be 8 dx. Okay, so I need an 8. So if I put an 8 in the numerator, then I need to compensate with a 1/8. So rewriting this integral, we have 1/8 times the integral of du over the square root of u. And of course we want to change that square root of u and make that u to the negative 1/2. So we can integrate using our power rule. Okay, so we need to add 1 to the negative 1/2. Negative 1/2 plus 1 is going to be positive 1/2. Divide by that new exponent. So dividing by 1/2 is the same thing as multiplying by its reciprocal. So I'm going to put times 2, and then it would be u to the 1/2 plus c. So simplifying 1/8 times 2 would be 1/4. And substitute your u back in, which was 8x. So that's 8x to the 1/2, which, you know, you can put that answer in, or you could actually write that as 1/4 times the square root of 8x. Okay, and that's correct. All right, so the next problem, we have the integral of x times the square root of x plus 7 dx. So notice on this problem, if you let u equal x plus 7, you can see that you have sort of a problem here. You have an extra x that's in front of that radical. So this is one of those change of variable problems where you're going to then have to rewrite your u equals x plus 7 and solve it for x. So if I solve that for x, I would have x is equal to u minus 7, and that's just by subtracting the 7 from both sides. So you're going to have to substitute in 2 places. And then we're also going to have to get our dx, which is in this case just du. So either way, du is dx or dx is du, whichever way you want to look at it. So substituting for x right after our integral symbol, so we have u minus 7, so put that in parentheses. And then we're substituting for the square root of x plus 7, that's going to be the square root of u. And of course, we're going to rewrite that square root as a rational exponent, u to the 1/2. And then we also are substituting in place of our dx, we're substituting du, because dx is equal to du. Okay, so to solve this integral, we're going to have to distribute this u to the 1/2. So that will give us u to the 3/2 by adding our exponents, 1 plus 1/2, minus 7u to the 1/2. Okay, so use your power rule. So add 1 to 3/2, which would be 5/2, and divide by 5/2, which is multiplying by the reciprocal. So 2/5 u to the 5/2. Okay, add 1 to 1/2, which would be 3/2. So multiply by 2/3, and then the 7 times 2/3 would give us 14/3. Okay, and now we need to substitute our u back in. So 2/5 times x plus 7 to the 5/2 minus 14 over 3 times x plus 7 to the 3/2 plus c. It just takes some getting used to with WebAssign. You have to always watch what you're doing when you put these answers in, because every time you put an exponent in, unless you use your arrow key or your mouse to move back down, you're just going to keep on typing up above it. Okay, let me clear this so everyone can see that. All right, and that is correct. And then our last problem, we have the integral of x plus 2 times the square root of 3 minus x dx. So if I let u equal 3 minus x, your du is negative 1 dx. So as you can see, again, we have this extra stuff in the front of the radical. So what do you do with it? Well, that tells you you need to use another substitution for that. So we're going to have to solve for x again. All right, so if I move my negative x to the left side, it'll become positive x. And then I can move my u to the right side, so I would have 3 minus u. Okay, and then dx would equal negative du. So either way you slice it, you're going to have to compensate with a negative. So if you substitute for dx, you would have a negative du. So I'm just going to pull the negative to the front. So we have negative integral. All right, so your x plus 2, you're going to have to add 2 to what your x is. So my x is over here. I have 3 minus u. So I'm substituting that over here in place of the x. But I have to add 2 to that. So that's going to be 3 minus u plus 2. And then we have the square root of 3 minus x. Well, remember 3 minus x was what we let u equal in the first place. And so that's going to be the square root of u, or u to the 1/2. And then I'm going to put my du. So dx was negative du, but I've already compensated with a negative in the front. So we can combine the 3 and the 2. So negative integral of 5 minus u times u to the 1/2 du. So we need to distribute. So that's 5u to the 1/2 minus u to the 3/2. That's adding your exponents, 1 plus 1/2 du. So the integral of each of those, so add 1 to 1/2, which is 3/2, and divide that by 3/2, or multiply by 2/3. So I think we're going to get 10 over 3, and we have a negative in the front. So negative 10 over 3, u to the 3/2. That should be correct. And then we have a negative times a negative, which is a positive. We're adding 1 to 3/2, which would be 5/2, so that's going to come out positive 2/5 u to the 5 over 2. And of course the plus c. So negative 10 over 3, substitute the u back in. So 3 minus x to the 3 over 2 plus 2/5 times 3 minus x to the 5 over 2 plus c. Okay, and that is correct. So thank you for watching, and stay tuned for the next one.